The forward converter has similarities with the flyback converter. But the main difference here on the transformer is that the start of the secondary winding is on top and pointing the same direction as the primary winding. We get a switch in series with the primary winding, and again we have a diode here. Furthermore, we have that freewheeling diode taking care of the inductor current later on, and the output configuration with the capacitor and the resistor are exactly the same as in the flyback converter. Furthermore, a forward converter has the demagnetization winding with the diode down here. During the on time of the switch from 0 until the duty cycle, the primary winding is in parallel with the input voltage source. So we have the full input voltage across the primary winding, short circuited by the switch down here. Through Faraday's law, we couple that voltage over from the dot to the non-dotted ending of the windings, and we have a positive voltage across the secondary winding this way around. That voltage forward biases this diode here. The current on the secondary side, which is flowing in the primary side into the dot here, and at the secondary side at the same time out of the dot, Ampere's law, N times the current on the primary side equals N times the current on the secondary side. And finally, charges the capacitor and supplies the load. As we have a positive voltage from the dotted end of the transformer windings to the non-dotted end of the transformer windings, following also Kirchhoff's voltage law, over here we have a positive voltage from the input voltage and the positive voltage from the demagnetization windings. That forces a positive voltage from the cathode to the anode of that diode here, which therefore is in reverse mode and is blocking. During the off time of the switch, from the duty cycle until the period time t, switch down here is open, therefore we cannot have any current flowing through the primary winding, designated by N1 here. But we had a current flowing into the dot of the transformer windings, and that current, that magnetic flux, might force further current flowing here, and that current returns to the source and pumps energy back into the source, charges the output capacitor of the previous stage. On the secondary side, we had current flowing through the inductor, which would keep flowing because that's not a coupled inductor, that's not a transformer, that's just an inductor, and the current cannot jump. Therefore, it would forward bias the freewheeling diode down here, similar to the case of a buck converter, and keep charging the output capacitor and supplying the load with the load current. As the diode down here got forced by the current of the demagnetization winding here to be on, that means that this demagnetization winding here has a voltage across it, which is equal to the input voltage, as those two elements are in parallel, forced by the conducting diode. Therefore, we have a voltage from the non-dotted end to the dotted end across the transformer, and Faraday's law dictates that this voltage is getting also transferred to the other windings. On the secondary side, this voltage is equal to the blocking voltage across the diode here, as the freewheeling diode is turned on and shorts those two elements. And on the primary side, that means that the voltage up here is in series with the input voltage, and equally to the flyback converter, our switch has to block a higher voltage than the original input voltage of the DC source. The output voltage is a scaled version of the input voltage, where the scaling factor is the duty cycle. The so-called turns ratio, N2 divided by N1, the number of turns on the secondary side, divided by the number of turns on the primary side, is a further constant in that equation. But compared to the buck converter, The duty cycle is limited here. We cannot go all the way to 100% duty cycle, as we need to leave some time for the demagnetization of the transformer, which is taken care of by that extra diode and that extra transformer winding up here.